Okay, the next one is going to be on subcooling. So subcooling is going to look at the saturation temperature as the liquid comes out of the condenser. So let's do, go away, let's do this little bit here. So here's our condenser. We got liquid coming out, and we're going into our liquid receiver, and then out and over to the TXV. Okay, and we have line coming in this way from the compressor, and we have this coming over from the evaporator. Okay, so condenser, actually, as long as we're doing this, evaporator. That is the crappiest drawing. Sorry guys, I'm going to start that over again. As long as we're doing this, I might as well do it right. So we're still in blue. So evaporator over TXV, compressor over all right, condenser, our evaporator. Okay, and we're going to measure superheat or subcooling right here, or someplace in this general vicinity. And we're going to get our saturation temperature from our gauge set, based on the pressure. Okay, and the temperature here based on thermocouples. Actually, all you need is one, so only a thermocouple. Okay. All right. So it is this. Now, why is subcooling so important? Well, subcooling is the best way to adjust a TXV. Okay. Now, we've talked about superheat. Okay, we've talked about superheat, but as long as we are in this mode, superheat, subcooling, try to get this sorted. Superheat's best used when we have a piston metering device or a capillary tube. All right, and it's just a matter of what kind of refrigerant we want to add to things. It's also a good place to start making the adjustments to the TXV, but it's not the fine adjustment to the TXV. The subcooling gives us that fine adjustment, okay? So, what's really happening is when we adjust the TXV, we are metering the amount of refrigerant liquid that's going to the evaporator. So the amount of superheat, by the way, as long as you're here, we're measuring saturation temperature here, and we're measuring line temp here, and these two lead us to superheat measurement, okay? But as we adjust the TXV, it's changing the amount of refrigerant that's flowing through the evaporator, and it's either going to boil sooner in the evaporator or later in the evaporator, and that'll change the temperature in the line after saturation. Okay, so actually boil off more or boil off less. It's still vapor when it gets to the compressor, and the compressor is going to push it through, but now there's only so much refrigerant that the condenser can reject to the atmosphere. So if it can't cool itself down far enough, it won't achieve the proper subcooling. So that is why the TXV makes the adjustment to the subcooling. And when that happens, we can tune this thing really precisely. Okay, so let's go through this. All right. All right, so let's do a couple things here first. There's a few pros and cons when we do this. Okay, so first thing is let's check. Maybe the best way to do is a setup for proper subcooling measurements. Okay, one, clean the filters. We want good airflow. Okay, and along with that, you can clean the condenser. If the condenser coil is dirty, there's no hope of achieving the right numbers. Second, we'd like both indoor and outdoor temperatures to be above or equal to 70 degrees Fahrenheit. Okay. 3, be patient. Wait 5 to 10 minutes. For the system to respond. Okay. All right. All right. Number 4. Check the evaporator. That saturation temperature here is 32 degrees Fahrenheit or higher. Okay. And five, red hose to service port. And thermocouple it's about 3 inches. Okay, so red hose, because we're going to measure the high pressure side. So put your red hoses on the service port. Service port is either going to be on the compressor, which would be too far away. We'd like to have the one that's on the liquid receiver. So the service port on the liquid receiver, and then you're going to measure the temperature within 3 inches of that service port. Okay. All right. So number 6. Okay. We need the subcooling rating off the data plate. Okay. If there isn't one, 11 degrees Fahrenheit. If no other information available. Okay. And then we get down to actually doing the calculation. So now it's time to calculate. Okay. So those will get you set up to do things properly. And we want to make sure we can do what we're doing here. Okay. All right. So subcooling is this. Is equal to the saturation temperature minus the actual temperature of the line. Okay. And a couple things we can do here is to, well, we're going to do this. If, before we do the math, I'm going to give you these facts. If the actual T is less than the target subcooling, add refrigerant. Okay. And if the actual T is greater than target subcooling, and by the target I'm talking about the number off the data plate or the 11 degrees, you need to recover some refrigerant. Okay. All right. Now, the fun part of this one is you can be plus or minus 3 degrees Fahrenheit of error. Okay. So we can be 8 to 15 and still be okay. All right. Yeah, I'll give you an example here. All right, let's say the data plate has, example, the data plate TXV subcooling is 12 degrees Fahrenheit. Okay? And we're going to get some numbers here. Let's see, how do I want to do this? I didn't really set up any numbers, so we're going to be playing here. Okay, so we want to shoot for 12. Give me a second here. I'm going to pause for a second and set some numbers up for you. Okay, put that down there, come back to here. Okay, let's try these. Okay, so let's do let's find my equation here. Where'd it go? Saturation temperature and actual temperature. So let's do saturation temperature for this example is 105 degrees Fahrenheit. And our actual line temperature on the liquid line is 95 degrees. Okay, so subcooling is equal to 105 degrees minus 95 degrees, and we're going to be at 10 degrees Fahrenheit. So given the fact that this could be plus or minus 3 degrees Fahrenheit, this would actually be close enough. 11, and in this particular case, 12 is our target. So we could try to tweak it a little more, but we're within the ballpark of that. Okay, let's try another one here. Example 2, I guess we should label that one. Let's say we'll keep the target, or the TXV subcooling at 12. At 12 degrees Fahrenheit. But now we have a 110 degrees Fahrenheit, and we're alright, sorry, this is saturation temperature, and our actual temperature in this case will be let's make it we'll make it 90. Okay, so our subcooling is 110 degrees Fahrenheit minus the 90 degrees Fahrenheit, which means we have a 20 degrees Fahrenheit. And our actual subcooling, alright, and this is where I'm going to use these actual temperatures and the target subcooling up here. Our actual subcooling is 20 degrees, and that is greater than the 12 degrees. So in this case, we need to recover some refrigerant. Okay. And as long as we're up here, let's do this. I'm going to fix this up here at actual temperature. We're going to change this to actual subcooling. Okay, that'll make more sense to you. All right, so we're good. Now let's try one that goes the other way. So example number 3. So we'll leave the TXV subcooling again at 12. Now I'll tell you what, let's make this one 11 degrees Fahrenheit. All right, and our saturation temperature is 105 degrees Fahrenheit, and our actual temperature is 100. that means our subcooling is 105 degrees Fahrenheit minus the 100 degrees Fahrenheit. It means we have a subcooling of 5 degrees. And that one is less than the target of 11 degrees, and therefore we add refrigerant. Okay. Now, I want to make clear here, it's not always adding refrigerant to the system. It is adjusting the TXV, the stem of the TXV up and down. Okay. All right. That's all there is for that. You guys give those a few practice things, and we'll go from there.